rod does not slip. The diagram little bit. This is a rod. This is a point A and point B. And this is rough is telling. This angle, let it be 45 degrees. Now get into the different forces that are acting, the weight of the rod, then the normal contact. Now I think you should be very particular about the shape of the rod, the way the forces that will act on the rod, no, that is very important. I'll give some better diagram. Meanwhile, you try it. Huh? I'll draw the better diagram. This is a rod of mass m. Get all the forces that are acting. So how to get the direction of friction, everything, try to manage, you know. Don't bother torque. First get all the forces that are acting. Once you get the forces that are acting, you can manage further. First, the rod is in contact with the wall, vertical wall. So there'll be a normal reaction. This is by the wall on the rod, called Na. Then how NB should act along the rod. This is NB. The weight. How to get the direction of friction. If you say any direction, I will take it, then you are in a big trouble. Huh? You must use, now it's in equilibrium. The net torque about any point on the rod must be zero. Or about any point external to the rod also must be zero. The net force, net torque must be zero. Okay, to check the direction of friction. So what I do is like, let me define the torque about center. See, if we just say that friction upward, y means answer should be either upward or downward, then you are in a big trouble. Huh? So what I do is like, I'll define torque about C, about axis passing through point C perpendicular to plane. Then what is the torque due to mg? Will be zero. Torque due to nb will be zero. Torque due to na clockwise. Then who can balance that clockwise torque by na about C? The torque by friction only. So how the friction must act. Let me trouble you. I want to confuse you. Let it be like this. Now then, what is the problem? Torque due to Na, it will be like this. Huh? There is a perpendicular distance Na, clockwise. Torque due to friction also, clockwise. So what happened to the tendency of the rod will try to rotate clockwise, no? Net torque will be clockwise, but net torque should be zero. So what went wrong? The friction direction went wrong. So therefore, the friction should not be like this. Getting, no? So the direction of friction is not a guess. Put it like this here. Now write all the forces that are acting. Talk about axis passing through A perpendicular to plane. The system, so that everything lies in XY plane. All will set up a torque, you know. Mg will set up a torque. So what can be this distance? Let me write here mg into x clockwise. Then torque by the friction F into L anti-clockwise. F, this is AB, no? F into L. So now this should be equal to 0. What is X? This is 45 degrees. Huh? This is 45. This will also be 45. And this is L by 2. So shall we put it L by 2 cos 45? So this angle will be 45. So this angle will be 90. Yeah? This will be 45. This will be 45. And AC is how much? AC equal to CB is equal to L by 2. So what should be the X? X should be equal to L by 2 sine 45. Negative. So this I'll write it F into L. So what is F equal to? mg by 2 root 2. Find mu so that rod does not slip. It's asking to get the mu value. And then we should calculate that NB, no? How to bring NB? I'll equate forces along y-axis, net force on the system along y-axis. mg is balanced by mg. This is 90 degree. So what should be the NB now? NB should be equal to, this is, we'll do one thing, theta. This will be theta, no? mg minus mg plus NB cos theta plus F sin theta equal to 0. Why 0? Net force on system along y-axis should be 0. Now, what is F? So from here, what when I know F equal to mg by 2 root 2. Sin theta we know, cos theta we know. I'll get NB that one. If I know NB, then I can write F equal to mu NB. So let me simplify. mg equal to NB by root 2. F is mg by 2 root 2, 1 by root 2. So NB is equal to, I'll get it is 3 mg by 2 root 2. We know F equal to mu NB. Substitute these values. This will be our answer. Now, if the value of mu less than this, what happened to rod? Cannot be in equilibrium. Greater than this, it can be in equilibrium. Torque due to weight, torque due to normal contact, torque due to friction, torque due to tension. So it's unlimited. Huh? Sir, why you took torque about A only? Why not torque about B? Yes, you can do. Then you'll get NA. Sir, I want to find out NA. So you do one thing, torque. The problem is not over. This will be talked about axis passing through point B. You look at that one. So NA into perpendicular distance L cos theta clockwise. Then mg into this will be theta. Theta we took it like this, no? So this will be theta mg into L by 2 sine theta. This should be equal to 0. Solve it. You'll get that NA value. All things are known. We can find out everything. Equilibrium means very easier. Net force along X, along Y. But sir, what you took here, net force, why not net force along the incline? Yes, you can also write net force along the incline. 0. Net force perpendicular to incline on the rod will be 0. It's left to you now. As it is equilibrium, you can equate forces along any direction. Net force equal to 0 along any direction. As it is equilibrium, you can define net torque equal to 0 about any point. Are you getting no? So you choose such a point where calculations are minimized. I think this is the core idea of this equilibrium problem. If the system is in equilibrium, the net force in any direction must be 0 on the system.